To describe the transformations, we want to make sure that we recognize inside transformations from outside transformations and keep them separate from each other. So here we have this root function square root of x. The transformations on the inside are going to be everything on the inside of the square root. The transformations on the outside are going to be everything on the outside of the square root. So doing this one here, since the outside transformation looks much simpler, we're just going to do the outside transformation. So we know that the change in y, or the new y, so change in y is going to be the new y is equal to -2 times the old y. So we're just going to use that equation, times everything by -2, so we get 0, -2, -4, -6. So everything on the outside has to do with y's, and we just do everything with y's exactly how we see them. X's are slightly different. X's are done in reverse. So everything that we see here has to be done in reverse. So the times 3 really is a horizontal compression. The divide by 2 really is a horizontal expansion. -6 really is 6 to the right. +2 really is a shift to the left. Now we can simplify this and put this into factored form if you like, or we can just rearrange it. So I'm just going to rearrange it and do the undoing process. So my change in x is going to look like this. So my expression is, this is my new x, -6 divided by 2 plus 1 gets me back to my original x, and then that allows me to do this function. But problem is, I don't want this one. I don't want to go from here to here. I want to go from here to here. So I want to reverse this. So I'm going to undo all of this. So I'm going to go left 1 first, multiply by 2 to get rid of that, divide by 2. I'm going to go +6, and then I'm going to divide everything by 3, and that's going to get me back to the new x. So this is my new x here. This is the one I want. And this calculation will get me to there. So I can simplify this if I want. I'm just going to go ahead and plug in. So I'm going to go 0 minus 1 times 2 plus 6 is +4. Divide by 3, I get 4/3. And so this is a fairly complicated transformation, but really we can just easily simplify this like that. I'm going to plug in 1. 1 minus 1 is 0, so I get 6 divided by 3 is +2. Here I get 4 minus 1 is 3, times 2 is 6, plus 6 is 12, divide by 3 is 4. And then 9 minus 1 is 8, times 2 is 16, plus 6 is 22, divide by 3 gives me 22/3, or about 7 1/3. And there it is. I've done all my transformations. Now in factored form, just so that we have a complete picture of this, in factored form, if I was to write this in factored form, I'd have to expand out the brackets and factor out the 2/3. So this is going to end up being, to put this into the brackets, I need to then times by 2. That's going to be -8. Okay, so it's going to be x -8, but then I factored out the 3, so 8/3. I think that's right. Okay, so that would be my factored form. So this would mean that, oops, that's going to be 4/3, sorry. Okay, so this is going to be 4/3 when I put this into proper factored form. Okay, and that represents then where my vertex would end up. Okay, so my vertex has been shifted 4/3 to the right. Just double checking here. When x is 0, I get -2. Yeah, that's 4/3. +4/3. So I've gone 4/3 to the right, and I've got a horizontal compression of 2/3. So graphing this in my graph, 4/3 0, 2 -2 is a point there, 4/4 down, This is going to be 7 1/3, so 7 1/3 is about there, and then -6 is about here. So it's going to be a graph that looks like this. So there it is. There's all my transformations put together with my x's and y's. I did my y's independently of my x's, and I did all the x's backwards.